We will conclude this week's lecture with the law of total expectation and an example that relates to both conditional distributions and conditional expectation. Again, consider the partition B1 through Bn and random variable x. Consider we would like to compute the mean value of x or a moment of order n of random variable x. And if you actually just plug in the definition of the expectation, and in the definition of expectation, if you put in the law of total probability in terms of the distribution, you obtain these formulas. Okay, expectation here can be written in terms of law of total expectation. You have the conditional expectation, but conditioned on each of these events in the partition, weighted by their corresponding probabilities. And same goes for the nth moment. Okay. Again, now if you define random variable y to represent the events in the partition B1 through Bn, you can just write expected value of x as expected value of x given y. Now here you have two expectations, okay? This might be confusing at first. You see the expected value of x given y. This is a representation of the outcome of this partition, okay? Y here, okay? It's sort of a placeholder for what value the random variable y will take. So that means this here is going to be a function of random variable y, not x, because I'm taking expectation with respect to x, therefore dependence on x will disappear. So this expectation, this conditional expectation, will be a function of random variable y. And here, this outer expectation here will be over this function of y. But it will give me the quantity for which the mean of x is equal to. Similarly, you can do the same for the nth moment. Expected value of x to the n given y, it will give you a function of random variable y. If you take that expectation once more, you will obtain the nth moment of random variable x. And in fact, you can also define what is called the law of total variance, and you can actually compute the variance of x by conditioning it on some other random variable y, if that's easier. It's given as expected value of the conditional variance of x given y plus the variance of the conditional expectation of x given y. Okay, so this looks like a bit confusing, but it's not that difficult if you just plug in the definitions here. Okay, the conditional variance here and the conditional expectation here, you can just evaluate. You can just show that this equality holds. Next, we will conclude with an example.